Hello everybody, welcome to Chapter 6, and we're going to cover object-oriented programming. We're going to talk about what object-oriented programming is, and then we're going to look at UML, or Unified Modeling Language, and class diagrams. And then we're going to introduce our first object-oriented class. Then we're going to go into some of the basics of object-oriented programming, talk about several concepts like access modifiers, writing a driver class, reference variables, calling methods and objects, this reference. We're also going to look at class basics, part 2, default values, more UML, talk about local variables, and finally we'll talk about return statements, argument passing, and some specialized methods that you're going to use in the object-oriented programming. So without further ado, let's go ahead and get started. So back in the old days, so to speak, the primary method to code applications was to use a technique called procedural programming. And today, the in vogue technique is to use what's called object-oriented programming, or OOP, as you'll hear it said several times. But in procedural programming, or functional programming as it's also known, the main focus was on defining common functions or procedures that were used over and over again. And you could say that we were focusing on the verbs of the program. But with object-oriented programming, we shift the focus from verbs or actions to start thinking about things that make up our program. We shift the focus from verbs to nouns or objects. Now, an object can be defined as a set of data that describes the current state of the object and a set of behaviors that the object can take. And some examples of this include people, such as employees, customers, and students, physical objects, such as a simulation object, vehicles, components, or animals. And then also we have non-physical constructs, such as coordinates, complex numbers, data and time objects, and many more. So think about the car in the traffic flow simulation. What data might it have? What about its behaviors? Well, since it's a simulation, it would probably have data that describes its characteristics and state, such as current speed and direction of travel, maybe the number of passengers, or is it accelerating or not? What behaviors does it have? Well, what can a car do, right? It can accelerate, brake, turn, or maybe even crash. So these are all examples of ways to think about objects, and then we can start looking at how we structure our program in a way that it mimics the real-life application. So what are the benefits of using object-oriented programming? Well, programs are more understandable. That is, since people tend to think about problems in terms of objects, it's easier for people to understand how a program is split into those objects. So there's also fewer errors, since objects provide encapsulation or isolation for the data. It's harder for the data to get messed up. And you can think about this as a blueprint for how objects are made. In object-oriented programming, a class is a description of a job or an object. We say that an object is an instance of a class. So in other words, the blueprint tells us what the object should look like, but it isn't an object itself. Just like this blueprint of a house, it's not a house, but it tells us how to build the house. So it's the same thing. A class is a description of how the object should be made, and an object is an instance of that class. So we're going to reiterate one more time, just for good measure. A class is a description for a set of objects, and this description consists of variables, both instance and class variables, and methods, both instance and class. So these things altogether are what make up a class. Now, a class's instance variables specify the type of data that an object can store, while a class's instance methods specify the behavior that an object can exhibit. Remember our string objects? Well, we had to have an object to call their methods, like char at and index of methods. In contrast, a class variable stores data that is shared by all objects, and as such is accessible without any instance of the class. Similarly, a class method isn't tied to a particular instance of an object, and it can be called at any time. So the math and wrapper classes are examples of classes that use class variables and methods. So what is UML? UML stands for Unified Modeling Language, and it's a diagrammatic methodology for describing classes, objects, and relationships between them. UML is also widely accepted in the software industry as a standard for modeling object-oriented designs. And there are many different types of UML diagrams, but as an example, here's a class diagram. And in this class, we have the mouse class. And you can see that the first row consists of the name, and the second row shows the attributes or variables that belong to that class and their type. And the third row finally shows us what methods belong to the class. So again, this is the information about the state of the object, and these are the behaviors that the object can take. Of course, there's many other diagrams beside the class diagram, and these aren't really talked about in the book, but there are numerous examples, such as an object diagram, sequence diagrams, activity diagrams, or even state diagrams. And there's a lot more, but you're in luck because we are not going to cover them all. Just be familiar with what UML is. It's, again, Unified Modeling Language, and how to read the class diagrams for now. So that's really what we're going to focus on. But I encourage you to go out to the web and look up UML and look at examples as the class progresses, and start thinking about your designs in a way where you could actually diagram them out. So here you can see the mouse class, where we have a couple properties or attributes that describe our mouse. We have the age, with weight being initialized to 0. We also have its weight being initialized to 1.0 because it's a double. And then we also have this double % growth rate, which is declared but not initialized. And you should remember the difference by now. Then we also have a set of behaviors that are associated with this class, right? So we have set % growth rate, which is a method, and it takes a double as an argument, and then it calculates, or it sets the growth to whatever we pass in here. Okay, we're going to talk a little bit more about this as an access method, or accessor method. And then we also have this behavior called grow, which is going to take whatever this mouse's weight is, and we're going to talk about this keyword right here, but it takes its weight and calculates how much it grew for that particular year or day or whatever age is. Okay, it says, oh, age of mouse in days. Okay, so it's going to add 1 to the number of days and modify its weight based on its growth rate times its current weight plus some constant. And then finally, we have display, which is going to print out its age and weight using the printf function. Okay, so this is the mouse class. Notice that there's no main method with this class. So right now, in and of itself, this class can't do anything because there's nothing to drive it. So we're going to have to take a look at a driver here in a little bit that's going to actually utilize this class in a program.